The opposite or the inverse of multiplication is to divide, correct? All right, now in matrices, we can't really divide matrices. So instead of saying divide it by 2, what we're really doing is we're multiplying by 1/2. Because 2 and 1/2 are multiplicative inverses of each other. They make 1. We get the identity element of multiplication. And we have to do that to both sides of the equal sign, right? So we would get 1x, and then 8 times 1/2, it would be 4. We use the multiplicative inverse on both sides of the equation. All right? So if we think about matrices, if we have some matrix A, what would we need to multiply it by in order to get our identity 1, 0, 0, 1? What would be its multiplicative? Well, this is a matrix, so how do we write the inverse of A? We just did it on our calculator. What goes on the top? With the little -1. Yeah. Okay? So A times A -1, or A to raise the -1 power, or the inverse of A, gives us that identity. And we're going to use that to solve systems. Okay? So now look to the left. I'm going to give you a minute to write down. AX equals B, where A and B represent some sort of matrix, and X represents a matrix full of variables. So if I want to solve this matrix equation for X, I have to get rid of this A. So I'm going to multiply by A inverse. Now let me rewrite it down here.
We have a cheat sheet for a test. Like an index card. Half of an index card.
See the big butcher paper up here? There's your big cheat sheet, okay? Sure. So A inverse times A, that like cancels out, just like this kind of cancels out and gives us 1. So that makes 1x would equal whatever the A inverse times B is. Okay. We're trying to figure out where these two lines are going to intersect. We need an X and we need a Y. I do not need to talk over you.
I'm sorry.
I don't need any more. Okay.
Do we have to write all this?
We're done your system.
Using the piece of paper.
We're writing this on the green sheet that I gave you.
For real?
Yep.
Alright.
So to make matrices out of this system, we're going to look at just the coefficients of x and y of the variables. Notice that the system is in standard form. X plus y equals the number, a constant. So if I look at this one, I'm going to write -2, -7, -2, -8. Just the coefficients. We're going to let that be matrix A. That row represents the first equation. Second row represents the second equation. The first column represents the coefficient of x. The second column represents the coefficient of y. Times our variables that we have. Because if we were to multiply this back out, it would be this row times this column. Negative 2x plus negative 7y. Equals, our matrix B is going to be our constants, the part after the equal sign. Negative 3, negative 4. So if you have not done so, please write what I have here in blue and label that this one is A. This is our X from what we had before, and this is our matrix B. Just like the previous slide, we're going to let the calculator do all the work for us. I need to multiply both sides of this equation, AXB times the inverse of A. And if I do that, I need to type in my calculator, A inverse times matrix B. Okay, so we're going to put this in our calculator and it's going to tell us our answer. I'll give you a minute to finish writing. The calculator steps are in the upper left-hand corner of your green sheet. So that's where I'm pulling what I'm going to push on my calculator for your future reference. Okay. So we have to put in matrix A, and we got to put in matrix B in our calculator. So let's do that. Go to your calculator. We're going to put in matrix A. And it is a 2 by 2, 2 row and 2 column. And it was negative 2, negative 7, negative 2, negative 8. So all the coefficients. Anybody need help getting to the screen? I need to hit enter. Negative 3, negative 4. Put in matrix B if you have not done so. And now we're going to ask your calculator to do A inverse times B. So we're going to hit second mode. Go pick up matrix A. Inverse times matrix B. And there's our answer. So what would X have to equal? What it is. It's the first one, negative 2. And Y would be 1. Let me go back.
I get that.
You get negative 2 and 1. Yes. So matrix A, what are we going to write? Going across. Read it off for us, Mr. Tank. Negative 5. Okay. All right. Times our variables x, y, z. There's our matrix X. Equals our constants. Our constants are 21, negative 7. 2 are the numbers what? Oh. All right, so we're going to put this in our calculator, guys. Is there a shortcut? No, I'm showing you the shortcut. If we were going to have to do this by hand, guys, if we'd have to do this by hand, we'd have to find the inverse of this. So we'd have to do 1 over the determinant, right? And then we'd have to do like by minors, which is in your textbook. It's very long and detailed, or by diagonals. Yes. All right, so A and B. So put in A and B in your calculator. And everybody have it written down? Am I ready to go? Okay. So let me clear this out. Second, x little negative 1. Go over to edit. And put in your matrix A. How big is matrix A? 3 row, 3 column. 3, negative 5, 6.
This is a weird test.
Is it fractional? Or? Okay. And it has decimals?
Yeah.
So it's more in line with like maybe what would happen in the real world.
Well, I
Right.
put it in the front.
Yep. Okay. Anybody need help getting to matrix A typed in? Let me know.
I've got it in fractional mode.
Okay. Matrix B. You go into the matrix like the movie. Going into the matrix? All right, and it was, how many rows does the matrix B have? 3 and 1. So it's a column matrix, and we would have 21. Second mode. I get caught up to where you all are. I see everybody kind of waiting on me. Second, x negative 1. I want A inverse times B.
Yeah.
Okay. Now, if you need fractions, you remember where that is? It's under math and frac. So you math frac it and hit enter. Yeah. So it's some ugly numbers, but nonetheless, could you imagine having to try to do that by hand and getting these pretty ugly numbers? You get one number and then you have to like sub it back in and stuff and work with it.
They teach you before calculators were invented.
Mm-hmm.